talked about all the critical information that you need to include in the RFQ before sending it out to the supplier to have them quote on providing these parts. But before you do that, we really need to start by defining what is the part that we want the suppliers to produce, and are the suppliers really capable of doing these parts as we've defined them, or do we need to redefine the parts in terms of the supplier's capability? A lot of the times, we want to bring in a completed an assembly with everything possible to minimize the work for our production operations, but that may not always be the most practical, particularly if it's going to force the suppliers to set up unusual operations or unusual outsourcing. So for example, when we were at Zenith Solar and we were looking for a supplier to provide what we called the encapsulation box, which you're seeing here on the screen. So this is concentrated photovoltaic mounted to a channel. It's got a lot of electronics. It's got a lot of plumbing gear attached to the box. Very complicated assembly that would really require a rather sophisticated supplier to make the parts. And this is what initially engineering came back and said, well, really we need to source this to a supplier with a clean room activity. And what we found was it would be much more efficient if we broke this into various components. We all assume that as the volume for a part goes up, the cost per part should come down. But what's the real mechanism behind this? So if we're talking about a manual assembly operation, we're talking about a job shop where every part is one-off. The operator works on one part at a time. Your costs for a manual operation are pretty much fixed. There may be a slight learning curve with the initial couple of pieces, but really you shouldn't expect to have a significant decrease with volume. On the other hand, if you look to using robotic or automated assembly, you've got a very high initial price for setup and establishing the units, but once volume becomes sufficient, those mechanisms, those processes will result in much lower piece costs. So typically what we find is you're going to use manual assembly for the very low volume, particularly prototype parts. You're going to use programmed or robotic units that can be easily reprogrammed to make different parts. So you use robotic assembly for I'll call it a mid-level of volume, and then as your volume increases, then you begin to look at automated volumes. Now, superimposed on here, we've got wood products, which are typically manual operations, but wood can also be laser cut. So a laser cut would be an example of robotic assembly that the laser cut machine is programmed for the particular item that it's building. Metalworking shops typically are manual, but again, metal is very often CNC'd or laser cut. So those would be example of robotic assembly. And injection molding is probably more like fully automated assembly. Same thing with metal casting, and certainly metal stamping is typically a fully automated assembly. So you see the progression from wood to metal to low volume, low cost plastics to high volume, high cost plastics, and certainly as we move up, as the volume increases, metal stampings are the most efficient. Metal stampings, if we're talking about volumes greater than 100,000 units a year, metal stampings can be processed in 10 seconds. Yes, investment cost is probably upwards of $1 million, but you're getting a very lowest piece price cost with metal stampings. Injection moldings, you're really looking at parts that are somewhere between 10,000 and 100,000 parts. You've got tooling costs that are anywhere from $30,000 to $1 million, depending on the complexity of the part. but you're injection molding a part typically every 40 seconds. Again, it depends on the part. Thermoforming, your operations are 2 to 5 minutes typically. It's a slower process, but your investments are much lower. Thermoforming works great for volumes that are between 1,000 and 10,000 parts. And below that, you're probably talking about working with wood and metal, and mostly manual assembly or CNC and laser cut, robotic programmed cuts. Now, really critical to your RFQ, because you're going to be required to provide, or you're going to want to provide, a design to the suppliers with the RFQ. And the question for you is engineering and design complete? If it's not, don't issue the drawing, and don't issue the RFQ, because the RFQ will be incomplete. If engineering is looking for supplier inputs to the process before completing the design, there are ways of doing that. That's typically what we call an RFP, request for proposal, or an RFI, request for information, not an RFQ. An RFQ, you're asking the supplier to commit time and resources to really quote the job. He's expecting that this is a real project and that it's fully defined, and you want him to make that effort so that you get a very valid RFQ. If you're still changing the design, you shouldn't be doing that. You're wasting the supplier's effort, and if you do that, you're not going to get the same efforts on the next RFQ from that supplier. So, differentiate: is the drawing complete? Is the drawing appropriate? Is it ready to hand out? And if it's not, then you're not ready to issue your RFQ.